All right, hi everybody. Thanks all for joining us today. Let's see, hopefully kind of the screen sharing. Let's start with that. So thanks for, I know it's a busy time for everyone. Hope everybody's staying safe and with your family. So today's webinar is about Kubernetes cost optimization. And some of the tactics that you could use, and also basically really with a story about how we did it ourselves using our Magalix product to cut our infrastructure by almost 40%. So without further ado, just kind of a little bit about me, and then we kind of will jump into the topic. So my name is Ahmed Badran. I'm the CTO here at Magalix. I started kind of in the whole cloud thing back in AWS. I worked for AWS back in 2005. So those were back in the days when the whole kind of idea of the cloud is still kind of emerging. And it was interesting to see, kind of the progression and how the industry evolved over time, and the entrance of others in the cloud provider business, but also the architectural evolutions from, the monolith to the microservices, and kind of the DevOps culture, kind of really syncing kind of your dev team with your operation team and hopefully driving more of that. And I've seen that obviously after I left AWS and Amazon, and I worked for a few other companies. It was interesting to kind of see the journey that other teams and other companies, the pains they're also going through as they kind of migrate to this new cloud native stack and this kind of new way of doing things. And just like any technology, everything has its cycle, and it kind of drives new innovation along with it. But also it adds a lot of challenges, and now the new and different ways of using the technology comes with its own burden of understanding a variety of things. So let's talk about one of those challenges really in the cloud native journey. And I call it the cost versus performance challenge. As your development teams and engineering team is building these new systems and trying to migrate your kind of monolith and move into these microservices, you distribute your architecture. And with that distribution also comes distribution of responsibilities. And it becomes harder to track what is going on and who's working on what, and kind of having a centralized decision making. You distribute your decisions as well as you distribute your architecture. And that's a key challenge really that a lot of people don't think about upfront, but eventually they catch up to it, or it catches up to them, and they realize the problems and challenges that comes with that. So the cost versus performance, if you think about the engineering building their system, usually they're just thinking about my application, my database, the performance of it, and probably assigning as much resources as possible. Like if I have an application, oftentimes the engineers are not going to spend a lot of time to figure out exactly the right tuning, the right amount of resources. So they will just kind of over provision. And that obviously to avoid any performance issues, your database, your applications, all the resources possibly you could. And that works fine until a certain point where at the end of a month or at the end of a quarter, when the CFO is looking at the costs, or your CEO is looking at the cost and realizing like, this is a lot. As we adding new feature, it just suddenly the cost of everything we're deploying now is kind of skyrocketing. And that's end up resulting in some interesting conversation and interesting challenges because they want to cut costs and they want to understand where is all this money going. So if you leave it to the CFOs and some of the accounting teams and that, they will start trying to push back and start cutting the budget and trying to set some limits and trying to trigger some cost savings, which could come also at the peril of performance. Because when you remove these resources, suddenly now your databases are struggling. You don't have enough CPU power or memory to kind of support maybe some of the spikes you see in your traffic. So there is this contention certainly between the cost and the performance. And you are not alone. This is not something because you just new to this. I mean, even major companies, even at Amazon when I was there, this is something that they obviously invest heavily on. But if you're a small company, you really focus on kind of your business, not the infrastructure and all of that. What do you do? And that's kind of the story here, basically what we want to cover today. So let's talk about the objectives of what we hope to achieve. So we'll talk, hopefully, we'll try to cover this topic in a way so you understand capacity, at least at high level, and how to analyze your cost of resources. We'll talk about something called the use method, which is very helpful as you analyze your infrastructure. Also, we'll talk about some cost saving tactics that you can employ in your organization or within your system to gain some of that. And then as you're doing this, you need to identify where are those wasted resources, because that's usually where the cost, the overpaying comes in, is you want to find those resources and you want to have easy ways to get to it. If it's going to take you a very long time just detecting where is your waste and how to save, well, guess what? You are just now adding additional cost of having people from your team, your most valuable resources, now spending time tracing things. And now you have to question, is that even worth to save like a few $100 here or there? Well, your engineers are much more costly than that, and their time is more valuable, and you want them to be working in your most business customer facing value. As you go through this exercise of cutting cost or saving or at least eliminating waste, you want to make sure you're doing this in a way that does not impact your performance, because that's the worst thing to have, is cutting your costs, but then also impacting your performance, getting into a performance degradation issue. And we'll show you how Magalix also could help you in that journey and making some of those steps a little bit easier and more automated, because that's really the trick. That's the trick of how you scale and how you find those opportunities, is through automation and data analysis, as opposed to you doing it manually. So let's leverage basically the compute power that push this revolution that we are in also to our own advantage and helping us detect those issues. All right, so let's start with a true story, because this is how it happened. Let's motivate this instead of just talking about some hypotheticals. This has actually happened to us. Me and kind of the operation team, we got this email one day from our CEO. You know, is our spending getting worse than last month? We can't sustain the spending rate on infrastructure. And I'm sure many of you probably could relate to this, because in one way or the other, this conversation, doesn't matter how long you keep kicking the can down the road, the conversation is going to happen at some point. It's like, hey, the spending on this infrastructure is just going out of control. Just like your top line is important to you, your bottom line is just as critical. And the bottom line is driven often by your infrastructure costs and operation costs, especially when you're on a SaaS business. So we got this email, and obviously that motivated us to start looking into the problem. You know, do we have wasted resources? I mean, are we getting this money because our application really needs this? We have the load has been increasing and the traffic from the customer is increasing, therefore the cost naturally is increasing, or do we really just have wasted resources laying around? And then, okay, if that is true, that we have wasted resources and here is some low-hanging fruits, how can we identify them? How can we find them? You know, with our microservice, you have so many workloads and containers and, you know, in the hundreds. So are you gonna really manually go through one by one and try to find that? That is just tedious. That's probably not worth the effort if it's gonna be very manual. Also, as we do that exercise, we need to keep in mind, like, could these changes I'm making or these cost-saving efforts impact my performance? So these are definitely kind of how we start thinking about this problem. And as to start thinking about the solution, how to move forward is like, okay, what is our cluster utilization? Do we have a lot of underutilized resources? And who are those top offenders? There's always an 80-20 rule here. You know, you can't look at every container you have and try to, you know, eliminate every little bit of it. There is probably an 80-20, meaning 20% of maybe your workloads are probably responsible for 80% of your waste. So how can we find that? And is there a good, easy way to make this? And also make it systematic. So in the future, let's say it took us some time now, hopefully the saving and the investment we do today becomes easier over time as we try it again. So you want something that is sustained over time, that we can find those inefficiencies in our infrastructure quickly. You know, and just at the end of the day, our kind of SRE lead is like, you know, there's got to be a better way than trying to do this manually or trying to think about this problem in a very tedious way. So let's get to it, and just let's talk about kind of a little bit of just some context so you're all on the same page, and then we'll walk you through some of the tactics the SRE team and kind of our SRE lead took on to really go through this process. You know, ultimately what you want is, you know, we need to be greedy, right? You want to do more with less. You want to do more work, more workloads. You want to deploy more of your applications. You want to scale your system with less of your infrastructures as much as possible. That's kind of like, you know, the silver bullet if we can figure it out. So we want more performance from the system using the least amount of resources. So that's another way to define it a little bit, because oftentimes you're not going to have a cost target saying, I cannot exceed, let's say, $1,000 a month. And then I don't care about performance, just whatever performance you get me. There are cases where this is true, maybe with batch processing and some, you know, if I have excess capacity, then run these jobs and cap it at a certain amount of money. Sometimes that exists, but for the most cases, for most really systems out there, you're going to have some performance SLO, like a service level objective, or even an SLA defined by the business that you need to maintain. And within that, you start looking at the different options and which option of those give you the least amount of resources, right? Like if I need to maintain a certain latency or a certain throughput in my system, you probably want to define that, and then you're going to basically squeeze the utilization as much as possible without affecting this. And this is important. You have to define that first. What is your performance target? What is your SLOs, your service level objective? And that's going to be driven obviously from your SLA, your service level agreement. But let's dig a little bit into the capacity management. And there's really two aspects to it when you're thinking about capacity management, because cost and performance is all about your cluster and the capacity you have within. So sizing and isolation. Sizing is all about, do you have the right amount of resources assigned to your workloads? The right amount, that's a key word. You can throw a lot of resources at your application to make it performant, but that comes at the cost of paying too much at the end. Or you can cut costs too much that you don't have enough resources, so now you're having a performance problem. So the right sizing, it's like an optimization problem. It's like you get the performance and the cost at two ends of the spectrum, and you're trying to fine tune it to a point where you're meeting your performance objectives at the least amount of money spent. So you want to pick up the right nodes. So when we talk about resources here, in an infrastructure, it's your CPU, your memory, the nodes you have, the network, the storage. Those are, you know, commonly the major resources you're dealing with from an infrastructure perspective. The isolation is another aspect that is very important, because whether it's a multi-tenant system where you have multiple customers running on the same infrastructure, or even just different teams in your organization running on the same infrastructure, it's like we need to be good citizens. You can't have one workload spiraling out of control and suddenly impacting the rest of your applications. If you have an infinite loop in one of your applications, or if you have a memory leak, you want that to be isolated to that application, to that workload, without it affecting others. So you start thinking about ways to limit your workloads from hurting each other. Think of the leak and stuff. Now, to talk specifically about Kubernetes, when you're talking about isolation, sometimes that's what limits are good for, is to put a boundary for how much bursting capacity do you allow your particular application or a workload to consume before you limit it and stop it, or even kill that application. In the sizing, it's more about, because, for example, setting requests for your CPU and memory when you in your spec, that is part of sizing, right sizing your workload. And that is important because that's what the Kubernetes scheduler uses to know how much, where to allocate this the workload. And if you sizing it wrong, so you're giving it too much, you already taken away from some other application capacity in a way, or from the overall cluster capacity. So now to deploy a new thing, you have to add more nodes or more resources to your cluster, thus potentially wasting money. So those are the two dimensions. Now, to kind of elaborate more on just kind of in a simplified model, when you think about it, your nodes in a cluster is what provides the capacity. It's how many nodes do you have, and what kind of resources they have, you know. So that could be your node pool. and you want to be thinking about those and how you select them. So also there is right sizing for your nodes, and we'll talk a little bit about that a little bit more. And then your pods is what consumes that capacity. And what the Kubernetes scheduler is doing, it's a bin packing algorithm basically, and they're trying to kind of match these two. And when you don't have enough nodes, that's where you start running into trouble. So when your workloads are asking for too much, even if they're not using it, you're still taking away from others, potentially, other workloads capacity in a way. So really the problem is now, how can we think about this in a way? How can I analyze my infrastructure in a way so I can analyze this problem and find those opportunities? So let's talk about system performance analysis. And a common method called use method. And USE stands for utilization, saturation, and errors. And it's a way for you to analyze the system performance. Now, there's another method as well, just so you guys are aware, called the RED method, R-E-D, which is usually for service performance analysis. When you're thinking about microservices or applications of that sort, there is usually you want to use the RED method, R-E-D. R is for rate, so the traffic, how many requests are you getting, or your throughput maybe. The E is for errors, so how many failed requests is your service experiencing, and that's how you drive your availability numbers, obviously, for your service, the error rate, the errors. Now, the last one is D, which is duration, is how long things are taking. So that's a pipeline. How long is the pipeline taking to process the data? Or if this is obviously a service, this is the latency of your application, your service, your microservice. So that's usually the three kind of things you think about when you're thinking about a service. But here we focus on really on infrastructure because we're dealing with Kubernetes. Because honestly, the most costly thing for you're paying for is the CPU. And those are the ones you really want to be thinking about. So when we think about a system resource, we think about utilization, saturations, and errors. And you take those to your major resources that your system provide, which is your CPU, your memory, your network, your disk. Those are kind of the four major resources that you think about. So utilization is the average time the resource was busy doing work. And most of us are very familiar, like the CPU, when you look at your top or htop command, or vmstat or dstat, all these things could help you see, like, the user versus the system, the nice, the idle, all of that is kind of shown as a percentage, is basically showing you like utilization. Same thing for memory, obviously how much memory the system has versus how much you're actually consuming. Now, if you're thinking about a workload, it's basically the request that you gave to your workload, whether memory or CPU, and your usage. So you divide your usage by your request number, that's your utilization for that workload. Like you assign 5 core to your workload, and they're using only 1 core, right? That's like 20% utilization. So there's waste. There's 4 cores being wasted. You are allocating them to your workload, but they're not being used. Saturation is a very other interesting and a very important and often ignored aspect of a system performance. When you want to think about it, the saturation basically is the degree to which the resource has extra work that it can't serve. Basically queuing, stuff that is waiting. So your CPU, for example, IO wait is a perfect example, obviously, of that. It's like you want to read and write, but you're just waiting for the spindle to finish, or the controller for the whatever it is you're using. You are waiting. There is work to be completed, but you don't have enough resources busy that it doesn't have enough time to finish, or stuff waiting for your CPU to be available. If you have a multi-threading application and everything is requesting time from the CPU, and just there isn't time, so you end up just waiting for the CPU to be available. Saturation is a critical thing, and I'll talk about it. Errors are just the count, and there's a lot of things you can be looking at here as well. And actually, I put a link to the use method and from Brandon, who kind of wrote this and popularized this idea. So you can look at his link for more details, and you can see the Linux commands even to kind of start analyzing these. But we're going to be focusing here more on Kubernetes and the CPU and the memory mostly, because those are two critical. Those are basically where your money usually is spent is honestly the CPU is the biggest deal, and the node, the type of node, which kind of decide also the type of number of CPUs you have and the ratio with the memory. So when we're thinking about this, the utilization, like I said, it's you look at your usage and you divide it by your request. And that's how you get your utilization for your CPU or memory. And that's an important number to look at to identify waste. Saturation now is an interesting thing. So how do we look for this? Do I really need to go to this? Well, there is an approximation for it, which is your throttling. Throttling is basically, there is work to be done, but your CPU, you don't have the capacity to do that work. And that often is reached when your limit is reached. So when your workload has some work to do and it goes above the request and it hits the limit, if it's a compressible resource like your CPU, you will get throttled. If it's a memory, you will get killed. You get an OM kill. Now, here's an interesting question. Could you have a low utilization, which means like, oh, I have enough capacity, and have throttling problems or saturation problem? Actually, you could. Now that might sound like counterintuitive, but the reason is because oftentimes utilization is computed as an average over some window of time. So imagine the following scenario, and this is common in system that has really spiky traffic, where maybe some data processing happen or batch jobs that runs at a certain interval. So imagine you have a minute, and during that minute, at the top of the minute, some jobs get triggered every minute or every hour, right? So for the first 10 seconds or 10 minutes of that hour or that minute, a lot of traffic is happening and a lot of utilization. You might be hitting 100% utilization. But then for the remaining 50 minutes or 50 seconds, whatever the window you're looking at, there's not a lot of work going on. So your utilization go to like 1%, 2%. Now, when you look at that 1 minute window and your Prometheus is collecting the data and oftentimes you're gonna average things, what do you think the utilization is? Well, it's gonna be very low. It's probably in the 10% or 15%. So it looks to you that you have a very low utilization and you're missing those big spikes that happen because they happened really for a very short time. But your saturation number will show it. Basically, your throttling, if this is a CPU, you will see it in the CPU throttling metric from your Kubernetes cluster. And you will see a big spike. And that's how you know that at a certain point, you are hitting some limits and you are being throttled. And you know your limit number is probably not good enough. And maybe you need to increase it. Or you need to rethink about the design of your system. Do you really need all those jobs to run at the same kind of top of the minute? Can you spread it out a little bit over the minute or over the hour? So you can kind of even out the traffic. Because what's happening in that now is you have to really create a capacity for your system to meet your peak. And then the rest of the day, or the minute, there is just waste. This is, by the way, how AWS came to exist. The whole idea, what Amazon observed is during their year, in a 1 year, obviously all the shopping happened in like Christmas time. This is the peak. So they obviously, because they make all the money at this time, they want to make their capacity for Amazon really to meet that peak. So they end up buying all these resources, all these big data centers with all these compute machines ready for Christmas time. But what happened in January, February, the rest of the year? They're sitting idle. So Amazon is paying all this much money for nothing. But they have to have the capacity, otherwise the Christmas time, the system is just going to fall apart and they're just going to be out of business because that's where the money is made during these shopping season. So what did they do? Well, AWS, one of the business ideas behind it is, can I sell that excess capacity that I have really the rest of the year to other companies who do not have the same seasonality? Like back to school businesses, they kind of have a different seasonality when you go back to school. There's other things that have obviously certain different patterns. And the rest is history, like they say. AWS now is a whole other different business, and obviously they have a lot of other different business motivations at this point. But this idea of very bursty traffic is really problematic, and sometimes you really need to address it in an architectural way. But let's continue with this. So now we talked about utilization, saturation, and errors, and I hope you get a little bit of an understanding of where the problem could be. You certainly want to look at utilization to discover that waste, but you want to make sure also you're looking at your throttling. Otherwise, because if you look at your utilization, it's like 15%. It's like, oh, you know what? Cut the CPU back to like 2 cores instead of 5. Now you're saving money, certainly, but suddenly your throttling start increasing. If you're not watching that, you wouldn't even know it. Your customer probably will know about it first because the performance of your system start degrading. All right, so let's talk about then cost optimization tactics. Let's talk about this aspect of it and how did we achieve it here within for our organization really, and kind of what the SRE team has done. So it's kind of 3 aspects. Is the right sizing. So you think about your workloads and nodes, you want to make sure you're right sizing those properly. And then auto scaling for your workloads and nodes. And by auto scaling, I mean scaling out and scaling up, both aspects of it. Now the right sizing tend to be about the scaling up, or setting up the right resources. So it's kind of vertically. Do I have the right resources for the workload, or do they have the right node? And then the auto scaling here, usually we're talking about kind of the scaling out, or horizontal scaling, usually what we mean by this. Increasing the resources as demand comes in and reducing them as demand fades away, because that's how you save your money. Is because that's the other approach. If you can't fix your auto scale, the bursty problem, well, at least assign the resources when you have this burst and then take them away when you don't have it. So at least you're not paying for something you're not using. And the last thing, oftentimes people ignore this, is really the cloud providers give a lot of interesting discounts when you make commitments, or like reserved instance and stuff like that. And there's a lot of saving to gain from this once you understand your proper usage. All right. So let's hit some of those kind of one by one, give a little bit more context, and then we'll jump into actually using Magalix as a tool to help us with this, because this is a lot of tedious manual work if you were to do this by hand. So workload right sizing. Just like we said, you want to look at your requests and divide that kind of by your usage, and divide that by your request. And here's an example of just something where we have, obviously this is shown also the limit. But this is all about your requests here. If you look at the YAML file, request CPU and memory, and the limits. And oftentimes, honestly, in the beginning when you're developing a new application, you don't know yet what are the right size. So you're going to assign it something. You're going to pick maybe based on what you've noticed locally in your machine, or hopefully maybe in your dev environment, and then you deploy that to production. But you need to continue to monitor this. So you can come back. So if you notice, it's just a lot of tedious work to be done manually, where you have to deploy this and keep watching it. You have other works obviously to do, and you have other applications you're working on. So do you hand this over to your SREs? Now they are like, annoyed because you just picked random values, and they're kind of now struggling to figure out are they the right numbers or what have you. So we need a good tool, hopefully, to help us with this. But this is all about kind of observing and monitoring your usage. It relates to the requests you assign to your memory and CPU, and then trying to adjust it so you can really eliminate waste. Same thing happened for node right sizing. You want to make sure you have the right type of node. You often hear about compute optimized, memory optimized machines, IO optimized. You have to really think about what type of work and resource that is going to be in hot demand. And then assign your node pools accordingly so you have the right capacity. So why is this important? Because when you say something is memory intensive or CPU intensive, the node basically will have a certain ratio between the CPU and the memory. In our own analysis, actually the SRE team, our SRE lead, when he looked into this, obviously the cost, like a single CPU it's like 1 to 8. The cost of a CPU waste is really huge compared to the memory. So you want to make sure the ratios are right. Because when the ratios are not right, what happens is, let's say you pick a compute intensive type node, and really it's a memory intensive application. So what happens? As your memory demand increases, now you want to add another node because you don't have enough capacity. So you want to add another node to get more memory. So you add this extra memory, but guess what? You're also adding a lot of extra CPUs that you don't need, because you picked a compute intensive or compute intense type of node, which has a high ratio of your CPU to your memory. So now you are wasting totally a lot of CPUs just being added that are not being used just because you wanted to add some memory to your capacity. So the node right sizing is very important. This is just kind of a screenshot from, we use GCP to run our cluster. And you can see kind of, you have the different option. So have the right pools. Maybe some are compute intensive, maybe some are memory intensive, just depending on kind of the mix in your cluster. And this is a huge saving. This by itself probably accounts for maybe about 20% of the cost savings we were able to get. And it's because of us realizing as we do some other things, as we start adding other nodes to the pool, we end up adding like really not efficient nodes that have a lot of CPUs compared to the memory. And really, we had applications there that just really needed a lot of memory. So we switched that ratio and start using, have another pool where it's more memory intensive. And that really got us a lot of good savings, especially your CPU. You need to be really careful about consuming CPUs and make sure you have the right amount. Now, the workload autoscaling is another aspect. Just like we talked about, when you have this bursty type traffic, if you can't architect it out, it's just part of the nature. It's not something you control well. Kubernetes offers this horizontal pod autoscaler, the HPA, which could be based like in metrics like your CPU utilization, and it could see if if your utilization hit a certain target, it start adding more nodes. Sorry, not more nodes, more replicas, pods to this workload, so it could handle that extra traffic. And as that utilization drop below that threshold, it starts scaling down, which gives you savings. So I'm not consuming all those resources all the time when I don't need to. There is another thing as well, since there's some limitation to HPA, just looking at the CPU utilization, sometimes that's not the best metric to look at. CADA is another open source. It's actually part of the CF project. It's still, I think it's a sandbox, but we've used it really successfully. And what is nice about it, especially when you have events-driven architecture, it looks at the size of your queue. So if you have basically workers that read from a queue, it looks at that queue size. And if there is a lot of lag, if the queue length start building up, remember the saturation we were talking about, builds up, it start firing up more workers for you. As it goes down, it will shut it will kind of bring them down even to zero. Because if there is no work to be done, there is no need to have workers running, consuming just CPU and memory for nothing. So that's another project that definitely worth looking into if you haven't kind of seen this before. It's a great tool in your toolbox to help you with these sort of problems, even just for performance. Forget cost saving, and just really help you scale out as needed. There is also node autoscaling. So Google has this, and when you create these node pools, they have this autoscaling feature. And it basically, the way it could work, and this is to scale your nodes, so add nodes to your cluster, and take also nodes away. It works really in synergy with your Kubernetes, because it looks at pods that are not being scheduled. And when you have a pod that is pending, because there is no nodes to satisfy this pod requests and limits, request mainly, it will launch additional nodes for you. And also it looks at the utilization of the nodes, and when it realizes the utilization is going, really things are being underutilized, and that the existing workloads could be redeployed or the pods being rearranged, it will take a node out and scale it down if the remaining could fit the work you have. So it's another great feature, because you pay for these things, and why pay for wasted resources? Just have it auto scale the node pool for you up and down as needed. The last thing, and I'll just mention it briefly, I mean, GCP has these commitments, and you certainly could look into it for your CPU, for your memory, for your disk. Absolutely, for the CPU, that's where the savings. I mean, that by itself could be a 30% savings. If you really set up, exactly, like we use a certain number of cores per month, it's like 100 cores. Usually it's like 130, 150. Well, put something for 100 at least. Get some cost saving from that. AWS have the reserve instances and other things. There is just a lot of things that the cloud provider itself and type of discounts, like consistent usage, also give you some discounts. Using default node type instead of making custom nodes, that has its own savings. So there's other things here, but we'll leave this kind of outside of this discussion. It just kind of, there's a lot to do, and it depends really in your cloud provider. Now, we talked about some great ideas. Let's focus on one of those things, which is finding those, let's talk about the right sizing of your workload and finding those underutilized, wasted resources. Now, like we said you can do this manually, but then you have to have a lot of metrics. You have to be sniffing through a lot of data. And I'm sure you have better things to do than just doing this manual grunt work. So let me switch sharing the screen and go to actually our console to show you kind of how Magalix could really help you with that. Okay, let me stop sharing this and all right. So this is Magalix, our console, if you haven't used it before. So the way Magalix work, really, it's pretty nifty, it's pretty easy. What you do, you go sign up, magalix.com or console.magalix.com. Just sign up with your email. And all you do is, when you go to the first page after you sign up, there is just a kubectl command you run. And that will deploy our agent to your cluster. And what the agent does, it will collect some metrics and metadata from your cluster. What workloads do you have and what are the metrics? Do you CPU and memory? And based on that, we collect that data and analyze it, and then we give you recommendations. So obviously, Magalix also helps you with governance scenarios and enforcing policies and standards, which is a great thing, and you should check it out if you haven't seen that before. But really, the key thing here is what we call Kube Optimizer. The Kube Optimizer is the advisor we have. We have a set of advisors that analyzes your metrics and look for those problems, those sort of problems, waste or starvation also. So let's jump into it. So this is when you log in here after, obviously, you connect your cluster. You will see that this is our demo account, and you see we have a lot of different clusters here. And I'll get a nice summary like violations if you have certain standards set up, best practices. For example, like, if somebody's running a container as root, well, that's not a good practice. It will get flagged here, and I don't know exactly which workloads are violating this policy. Same thing also for like if it doesn't have a liveness probe. But you can see here the utilization is really bad. That's very low. But like we mentioned, you should not be fooled by utilization number by itself. So let's dig a little bit into this. This is more data. Actually, I can see here my CPU usage. We have some really nice charts here to kind of show you some good aggregate view of your memory usage and your CPU usage, and also kind of the different advisors. Now let's look at a particular type of advisors we have. So the issues, like I talked about, these are kind of best practices and governance related optimization. So let's click on that. We have few key things we look for. If you look at the first one, containers wasting CPU resources. That's perfect. That's what I need. And if you look at it here, we have 2 out of 12. So this particular cluster has 12 workloads or 12 containers. And we scanned the 12 and we found 2 of them to have CPU waste, basically. There is other things you can see like wasting memory. You can also see the opposite, starving. You can find workloads that have starvation. Well, we've done a good job in this particular cluster. We don't have really much starvation. And also we gave you a recommendation about node, the type of nodes and node pools you should have. So this is another thing you can look at, and we certainly have some recommendations. Let's maybe look at the node cost saving from the node advisor. So it says, for example, this is what you currently you're using is this 3 DS, and then we suggest a certain setup, and hopefully that will improve your utilization if you notice, and also will result in some cost savings. And we can show you kind of the total allocation based on the number of nodes you have, and you can look at the usage we have here. And this is kind of the request, and this is the total allocatable. So it's like, why do we have all this waste? How could we improve? So we already crunched the numbers, and we just gave you the recommendation. Take a look at this and see if it helps you. So this is, if you think about it, this is the node right sizing thing we were talking about. Now for the workload right sizing, let's look at this one. container wasting CPU resources. Oh, here are the two. Let's look at this. So this particular one, so we looked at, we have basically like a one core, and really we don't need that much. So let's look at the evidence here. If you notice here, this is our usage, this is our request, and this is our limit, which is one core. Here is the most critical thing. So it sounds like it's underutilized. Certainly we don't need all this much. So the question is, you should think about it, and that's why we show it to you is throttling. Is this workload being throttled? Because if it is being throttled, you probably don't want to mess too much with things here, especially your limit, because that will make it worse. You probably want to increase your limit. But since this is not being throttled, we have some recommendation here where we're suggesting you go down to 50 millicores. Now here's what is nice as well. You don't have to take this and go run it manually. You can actually automate it from within the Magalix console, because we have the agent running in your cluster. And if you give it the right permissions, it will be able to execute this for you. But let me not execute it. Let me go back. So I see two of these here. Let's go back to the optimization. Also for convenience, we just show you the automation, the automatable recommendations we have for you. And if you notice, we have the two for the waste CPU and one for the wasting memory. So I can select all of them or two of them. Maybe I'll select these two, or maybe these two, since they're for the same kind of application. So really, you can go at it. You can select multiple. Let's just pick one, just so we can see it in action. But you can select multiple and have that kind of be applied. So if you notice here, this is some runs from before. It's in progress now. So that means the agent picked it up, trying to execute it for you and right size the pod for you just with few clicks. And that's the beauty of this. Like I said, we wouldn't have gone through this exercise if we didn't have a tool or a product to help us. It's just too much. There's a lot of workloads and containers to sift through to figure out what is working and what is not. There's a nifty feature as well. I didn't show you because it's kind of a beta. Well, obviously I showed you here, like this is a small cluster, but what if you have a huge cluster, like our prod cluster, just a lot of data, and am I gonna look through all of this? And like we said, there is 80-20 rule. And I'm not gonna like try to change all my containers all at once, but we have this nifty visualization where we can show you basically your top 25 offenders. This particular cluster, of course, is very small, so and also doesn't have a lot of waste. But we can tell you exactly, like in a nice partition tree here, like, hey, in your default cluster and your default namespace, this is the biggest offender is this border back. And if you fixed it, you will save one core or 17%. So that's amazing. Now these things add up when you have a really large cluster, and you can look at the next and maybe just applying these two, that's sufficient. And actually, when we go back to the presentation, I'll show you the waste from one of our clusters when we did this. So in a nutshell, that was kind of really how you can use Magalix to help you achieve this easily without having to do a lot of the grunt work. Now let me switch back to the presentation. We almost done here. Let's see, all right. Right. So these are in the slide deck. You can see how we just kind of some screenshots that we already went through. This is one from our cluster, from our one of our big prod clusters. Look at the savings, 72 cores. That's a lot of money to save, and the same for the memory. It's like half a terabyte almost. We had like 440 gigs of memory we could save. And it told me exactly, here's my top 25 offenders, where if I click on them, that will be where my saving is. So I can just do few and really gain a lot of those savings right there, right then. So it has been really, really helpful to us. So this, finding those wasted, right sizing our workloads and then right sizing our nodes, that's really how we were able to achieve the 40%, more than 40% saving. Actually, in our dev cluster, it was more like 57% saving. Like we cut our monthly bill in Google for the dev cluster by like 57. Now, when you add all the other things, and our prod cluster was a little bit less than that, it really was a really nice, good saving. And the CEO is happy at the end of the day, and the CFO and everybody else. It's like a happy ending for a good fairy tale. And this is the result. Like, this is actually, it is now. The one I just was showing you before, the prod cluster, that was like 400 gigs of waste and like 73. It's like, we have like 6 here, and look at the course. Not a lot. And then this is our Google bill to the right here. And you can see kind of the dramatic drop down and the cost day to day. All right, so with all of that, I'm done. And Jahid, take it back, all yours.
Oh, thank you. And thanks for really wrapping that up in a nifty slide where you can literally just see the results. Super cool. We have a couple of questions here, and anyone else, we'll go through them in reverse order here, and anyone else as well who's in the audience, after we're done with these, you can just, you should all have the ability to talk. So after we're done with the questions, you can also chime in and ask if you have any questions. So first we can start with Abdul Rahman Assam, who says, can you apply the Magalix solution to a local Kubernetes cluster? Badran.
So Magalix would run in Kubernetes. So if you have a Kubernetes, you can deploy the agent that would work. The challenge becomes, so we can obviously also find in workload right sizing, because you have capacity by whatever machines you are running. And we can tell you here's the right level, because we have the usage, we see the request and limit you have, and we can help you with that. What is not gonna work is obviously the node right sizing, because I don't know what kind of nodes you have. We integrate with like AWS, and we understand the nodes that AWS have and the cost structure for them, and Google and Azure, and a few others, but I don't know the cost structure for your particular nodes, if it's something custom, something basically internal. So that piece won't work. The rest of it really should work just fine. If it's like an on-premise solution and you have your own data center, as long as Kubernetes, Magalix works with it.
Awesome. And let's see here. We'll go with, we'll first go with the Mohammed question and the one from, it looks like, Amr Imam. So how does automation work in the background? Does it apply the changes in parallel to all selected pods?
Right, so that's a really good question. So this is something where eventually maybe we can open more settings to the customer. But the way it works is, when, just like you saw there, when we apply the recommendation, it went to kind of queued. So we queue those things. So if I had multiple, actually all of them will be queued, and they will be queued in our system. And then the agent will kind of pull them one by one. And the reason we do this, because we don't want to impact really your infrastructure. This is something that could be taken live traffic, and I don't want to have a lot of restarts going on at the same time in your cluster. So what we do is we take them one by one, we apply the first change, and we wait. We make sure that it actually, the pod comes back up and running successfully before we say this automation is applied successfully, and then we take the next one. So we kind of phase it out a little bit. Also, we hope you have obviously a some rollout strategy as for your deployment. So not all your pods get started all at once. They sometimes need to restart in sequence, and that's kind of your rollout strategy that you specify, and we encourage you to have that, of course.
Cool. We have one. I just noticed we also have one in the Q&A section. So we'll do this one, and then we'll go to Amr Rahman. So we have, can you execute recommendations for changing node sizing?
So that one currently we do not support because it requires more integration with the cloud provider. It is something definitely we are thinking about. And I'll encourage you to reach out to us if that's really a scenario you're interested in, would like to chat more and understand kind of the use cases. The beauty of the cloud is, everything has APIs. So we certainly could do that if you just kind of click and we apply. But sometimes there is, a little trickery to it in terms of just the different cloud providers and making sure we're doing it in a safe manner. But it's certainly doable. We don't do it at the moment.
All right, and then for the node advisor, specifically for costs, we have, is the node advisor aware of the cloud providers I'm using?
Yes, we certainly do. Yeah, we know it, and that's why in the example even we had, the cost saving is actually specific to Azure, because that cluster I was using was an Azure cluster. So we pull the data regularly. We know what nodes they added. We know kind of the cost and the structure they have. And we use that to kind of help out with figuring out what kind of setup will give you a good cost saving and still meet, obviously, your workload demand.
Cool. So we have 5 minutes left, and we still have 10 attendees on the line. Folks, if any of you have a question, we've covered all of the questions. If you have any last questions, please, you're welcome to unmute your mic and ask it. Otherwise, if you don't, we will end here. So I'll give you about 10 seconds there. All right. Sounds like we had a decent wrap up there. No more questions. Thanks a lot for attending. You will get a copy of our capacity management Q&A. Sorry, I just got distracted reading it. Sorry, we had one person ask a question here. Licensing wise, Mohammed Shahat, can you, if you're still on the line, can you, oh, here we go. Licensing wise, do you have a model that a boutique consultancy could use for its customers?
That's very interesting. So I will give that to our product and marketing folks, since they probably could talk about that much better. We are a SaaS product, so there is obviously a lot of it, but I'll let you, I guess, answer that, Jay.
Sure. So we actually are working that out right now. We have, if you look at our pricing page currently as it stands publicly, we're priced on a per cluster basis. But if you are managing multiple clusters for multiple customers, we are happy to talk with you about a more scalable model. So Mohammed Shahat, if you don't mind, I can send you an email after this, and we can set up a time to chat, because we had exactly this. We have an exactly this type of deal being set up with another person that we met out of KubeCon. So this is not new to us, and we'd be happy to work it out with you as well. If you don't mind, I do have your contact details, so expect an email from me within the next 24 hours, and we can get on a call and talk about it. It would be on the enterprise side of things, but don't be scared. That doesn't mean it's the most expensive plan. It's more about just making sure that it fits your model and can scale with your customers. So, cool.
Sweet.
And thank you for that
question. Thank you, guys. Thanks, everyone, for attending.
Yeah. Thanks again. Thanks for coming, and you'll all get a copy of our capacity management ebook. And thanks again. We'll see you next time.
Take care, everyone. Bye.